Hello everyone, welcome back to my channel. In this video, we are going to learn about dimensionality reduction. So you must have heard about this technique. So before going into depth with dimensionality reduction in machine learning, we will understand why we need this dimensionality reduction or what is dimensionality. So as you know well that without data, we cannot create any model, like we cannot do anything in data science field, or you can say data science cannot happen without data. So whatever the model we are going to create, we need data. And if we are having the data, so in the data can have huge number of features, like even which are not required, those features can be in your data set, like maybe redundant data will be there or some missing values is there. So how to deal with these kind of data, like huge number of variables, huge number of features in your data set. So how to reduce those number of features into important features to create the model or any machine learning model. So for that, we are having dimensionality reduction techniques. Okay, so we will understand in more detail. But first of all, what is dimensionality? So the number of features, the number of input variables in your data set is known as dimensionality. Okay. So now when we are having huge number of variables and now we need to reduce the number of variables or input variables in our data set in low number of variables using dimensional reduction. Okay. So more input features we are using to make a predictive model, it can be very challenging task. Like if we are creating model and we are giving a lot of features to our model, definitely it is going to be very complex. It is going to take more space, more time, and definitely more computational power, which is actually a curse of dimensionality. Because let's say that we are going to create some models, and let's say we are having five models. Okay. So when we are having five models, when let's say that we are having five models. Okay. So five models we are creating, like M1, M2, M3, M4, M4, M5. Okay. So I'm creating M1 model by giving two features, right? And I'm creating M2 by giving four features, M3 by giving six features, M4 by giving, let's say, 100 features, and M5 I'm giving 1000 features, and I'm creating five different models. Now, if you will look here, I can provide all the features to my model. Is it a good way to create a model? Definitely not, because when you are giving all the input variables to train a model, it will create very complex model. Definitely, it will result into overfitted model. Okay, so what can we do? We can create a model by using less number of features also, and which will give us accuracy, more accurate results compared to this M5 model. So how we are going to decide it? Like six features. If we are giving only six features and we are creating a model like M3 model, it is giving us more accurate results compared to this M5. And to this M5 model, we have given 1000 features, but still it is not giving us accuracy as much as M3 is giving. So how we are going to decide it? So we can decide it using some techniques to come to a threshold value, like these much features are enough for our model to give the accuracy, to give the performance. Okay, so let's move and let's see that how we can understand this dimensionality reduction. So before moving into the depth with dimensionality reduction, we will understand the cause of dimensionality, because in this we are going to deal with the data, or in the data set we are going to have multiple number of features, like high or huge number of features, like okay. So how to visualize it? Definitely if you will be having a lot of features in your data, so it's not easy to visualize it. Let's take an example. You can see here, there is a very simple scatter plot is given. You can see it's a very simple scatter plot given between two variables. So on x-axis, you are having one variable values, and on the y-axis, you are having another variable's value. And based on that, there is a scatter plot. Like there is some correlation among these two variables. Okay, we can visualize it. It's easy. But what if we are having three features, three variables? How to visualize it? We can visualize it through this 3D plot. Okay, so you can see this 3D scatter plot. This 3D scatter plot is complex to understand. Okay, but what if we are having four features or five features or more than these dimensions? So what we will do for visualization? Let's say that for four dimension also we can use pair plot, but again, it's not easy to understand it. So for that case, we can do dimensionality reduction on our data. Okay, so how we can increase the performance of any machine learning model? We can increase it by using dimensionality reduction technique. So before going with the dimensionality reduction, let's understand more the curse of dimensionality. Here you can see handling the high dimensional data is very difficult actually, because it's not easy to visualize, it's not easy to understand the data when we are having huge number of features. Okay, let's say that if the number of features are increasing, the model will become more complex. It will take more computational power, or even it will result into overfitted model, which will not work well on the testing data or any unknown data. Okay, so higher the number of attributes, harder to visualize the data, and it also increases the space and the computational time complexity, which is not good for our machine learning model. So it's actually required or important to reduce the number of features, which can be done by using dimensionality reduction. Okay, now what is dimensionality reduction? Let's understand it. So it's a technique basically for reducing the number of input variables in the training data, because in your data set you can be having thousands of millions of data, millions of features, millions of variables, but we cannot give all the features to our machine learning model in the training phase. What can we do? We can reduce these features into low number of features by analyzing the data, by understanding the data, because our main focus, like, our information should not get lost while creating the model. Okay, so while dealing with the high dimensional data, it's actually useful to reduce the dimensionality of the data to lower dimensional data. Okay, even while keeping all the important information within the data without losing the important information. While converting the high dimensional data into low dimensional data, we will keep these information in our mind while creating the model. Okay, so high dimension like can be hundreds, thousands, or millions of input variables. So lower dimension, like you can say that you are going to convert high dimensional into lower dimensional data. Okay, so lower dimension, like less number of features you will be having to create a model. But how can we do it? Again, there is a question, like, because while converting the high number of dimensions into lower dimensional data, we need some techniques, we need some uh, algorithms. So here we are having some techniques in this dimensionality reduction. Let's say that feature selection and feature extraction. Okay, we are going to understand more in depth these feature selection and the feature extraction technique. So first, let's come back to the dimensionality reduction. So the number of input features, variables, or columns present in a given data set is known as dimensionality, and the process to reduce these features is called dimensionality reduction. As you can see in this picture, like we are having five number of features, but we can keep only those features in our trading data which are actually important to create a model. Okay, one more example. You can see that maybe we are having 4-dimensional data. We can convert that into 2-dimensional data by visualizing it, by analyzing it, and by keeping the important features to create a model. So all the dimensionality reduction techniques attempt to preserve some relationships between the points while reducing the number of variables. Okay, so there are some components of dimensionality reduction. So here one is feature selection, another one is feature extraction, which is also known as dimensionality reduction. Okay, so feature selection, you can say that we are going to use 3 different techniques, like one is filter, wrapper, and the third one is embedded. Okay, and the last is feature extraction, which is we are using to convert or to reduce the data in a high dimensional space to a lower dimensional space, that is a space with lesser number of dimensions. I'll create one more video on feature selection and the feature extraction separately, definitely. Okay, now you can see that in the dimensionality reduction technique, there are 2 components, feature selection and the dimensionality reduction, or you can call it as feature extraction also. In the feature selection, there are further some parts like missing value ratio, low variance filter, high correlation filter, random forest, backward features extraction, forward feature selection. These are all techniques we actually use in feature selection. And now in the dimensionality reduction, so there are some component-based techniques like factor analysis, principal component analysis, independent component analysis. And in the projection base, we are having isomap, TSNE, UMAP. So these are all techniques we will learn in more detail. Okay. So for today, that's all we understand about the dimensionality reduction. We understand about the curse of dimensionality reduction. I hope you like this video. If you do, then please do like, share, and subscribe. Thank you.